This is going to be the AlgoRhythms Capstone project presented by Dalton Shults,
Kameron, Keller,
Matthew Malley-Nichols.
AlgoRhythms is a mobile application that generates a workout from a given playlist. We use machine learning algorithms to section and segment a song based on the rhythm and timbre of the music, creating an interactive, engaging workout for our users. The application has four main components: the Flutter mobile application, Django REST API, and beat detection segmentation algorithm. Finally, the AWS Lightsail server. And here's Kameron to demo the application.
Right, so we begin with the login screen. When you press sign in, the app redirects you to a browser where you get to log in with your Google account. We're using OAuth 2 for this. Once you sign in, you're redirected to the application. And we have a couple options. We can create a workout or use a past workout. Let's create a workout. You can select multiple songs, and as you see, the total time of your workout increases with each song you select. You can also search if needed. Once you press continue, you can select a difficulty or a body split and a body split. Let's start the workout. So now it's downloading the audio as well as the data for where beat locations are, and it gives us this visualization. So I'm going to play that now. So you could see that this animation in the center of the screen was indicating when the user should rep. And then once the song changed to a different segment, we switched to a rest portion, and the animation changed for that as well. If you wanted to know what mountain climbers were, you could click this information icon. You could read some text about how to do that exercise, or you could watch a little video clip that demonstrates what that exercise looks like. Finally, if you want to redo a workout that you really enjoyed, you could hit user workouts and select a past workout. You could view information about it the same way if you would like to review it first. And then if you hit start workout, it will load that workout in, and we're back to the workout screen where you could work out to that song. And finally, you can log out of the application.
Thank you for that demo, Cameron. So our front-end application interacts with an AWS Lightsail instance, where on that Lightsail instance, we are using Nginx as a reverse proxy to make sure that to set up our endpoints to be able to be publicly accessible. Then we forward the traffic from Nginx to Unicorn, which acts as a web server gateway interface for the Django API and allows us to have different worker threads running interactions with the Django API. This also makes sure the server is more maintainable and reliable, since it will automatically restart it if it fails. And the Django API itself is interacting with the Postgres SQL database and some just hard files. It returns both data from the database and the files itself.
The Flutter application uses that data returned by the Django REST API to display things like the current exercise, what the next exercise is, as well as where beat locations are, so the application knows where to trigger animation. It also gets, as Matthew said, all the audio and video from that API to display it in the application.
For a database, we decided to use Postgres because the relationships between our data, for example, a workout is going to be made up of an exercise and a song, and a workout playlist is made up of a playlist of workouts. These relationships are consistent throughout our data and help us assemble it and present it to our users in a digestible form. For the Django API itself, we essentially have an endpoint serving JSON data to the front-end mobile application. For example, our difficulty and body split serves JSON data defining all the difficulties and all the body splits we have in the application. These are dynamically generated, so if you want to update the number of difficulties or the number of body splits, the mobile application will just query the database and you can update that there. We also have the ability to favorite a workout and get audio. So for get audio, we are actually retrieving the audio file of the song. And we also have another endpoint for get video that gets video. These are the only two endpoints that don't serve JSON data. Everything else serves JSON data.
So right now we are running our clustering algorithm on the actual EC2 instance. Whenever a file hits our file directory, when we place the file there, it'll automatically run our algorithm, which starts by taking the audio file. It builds a Laplacian matrix, which consists of beat features, which are the similarity from one beat in the song to another, and we then process a Laplacian matrix. We normalize it, scale it, reduce its dimensionality before passing it off to our actual clustering algorithm, which from the matrix of beats and features, we cluster different segments based on a version of Ward's algorithm, which we minimize variance in each segment at each time we cluster.
For future work in the Flutter application, we plan to build, or one thing to build would be responsive design so that the application could be used on both mobile apps as well as larger screens such as a tablet or TV. We also want to introduce audio prompts so that the user does not need to look at the phone constantly to know what they should be doing. Finally, we would like to do extensive user testing to really understand more about what users would look for in this app and areas that we could improve it and polish it so to give our users the best possible workout.
For the Django portion of the application, it would be recommended to build a test framework around the models and API endpoints, and then also have the ability to stream audio and video. At this point, we are just serving them through HTTP responses.
For the algorithm, we want to speed up the feature extraction and audio loading, because that bounds the computational time of the entire algorithm itself. So for the audio loading, we should use a faster library than La Rosa. We haven't identified any yet, but if worse comes to worse, you can rewrite the audio loading. And then also for the feature extraction stuff, we're also using La Rosa, so we can rewrite that in NumPy to have it be parallelizable. Additionally, in the clustering algorithm, we want to weight rest clusters better, so that we make sure we maintain a 2-to-1 ratio of work to rest clusters, or work to rest segments. And then for AWS, we want to implement CI/CD and utilize more of AWS's services, so that we can ensure that we have a scalable design. We could use AWS's Lambdas, EC2s, and API gateway to have the user or a front end hit the API endpoint, run up the Lambda whenever you want to run the algorithm, and then you basically pop up an EC2 instance, run the algorithm, return or place the output into the database, and then return the response.
Our final thing we would like to say is thank you to Dr. Patrick Donnelly for helping guide our project and showing us we could achieve more than we ever thought possible. So thank you.